So the last part of this is just looking at some questions where we can apply some concepts of these trig functions. And the main idea is to be able to use the symmetry of these trig functions to be able to find parts of it and recognize parts of it. So here I've given you a sine graph. So that's just regular y equals sine x graph. And I'm asking what angles will give the same sine value as 0.783. So it looks like this. Sine theta, we're trying to figure out this. Where is sine theta equal to 0.783? Well, there it is right there. There's a mark the point on the graph. And we're basically looking for where is it going to equal this 0.783 value. Well, looking at this, we can see clearly it's right there, right there, right there, right there, and right there. We need to know the angles, though, at which those occur. So the angles are along the x-axis here, the sine value is along the y, so I've got the sine value. I just need to figure out the angles here. And I can see that is a really nice one here. Okay. Actually, I'm going to do that in slightly different color. So there's one here, one here, one here, and there's one here, and one here. And there's a reason why I've done them in different colors, because all the green ones actually are pretty much related to each other. They're just related to each other by one period. So if you take a look at our graph here, so this is 2 pi. From here to here represents one full cycle. So notice we start there, we go one full cycle. Well, yeah, we get to the same point there. Okay, although we didn't start at the nice reference points, we're starting here. That still represents one full circle. We get back to the same position here. So if I want to find out that angle, well, we've been told that that angle is 0.9. Okay, so the graph tells us that the x-coordinate or this angle position is 0.9. I want to know that position there, so I'm just going to add 2 pi, one full circle to get to that point. Okay, so I'm going to call that point theta 1, I guess. And that is going to be 0.9 plus 2 pi. Now you can work out the decimal value of that if you like. I think it's something like 7. What would that be? 7.18 or something like that. And in fact, that if you take a look at those green angles, they're all just related by one period. So that represents one period as well. So I'm going to call that theta 2, I guess. And that's going to be going backwards one full period. So those three positions are basically just, repetitions of each other. Okay, so I'm just going to actually call that theta 1 as well. Okay, that's, although it's different angle, different position, it's still related to theta 1. The harder one's going to be, well, this red one here. Where is that on the x-axis? Well, we need to use, if we're going to do a problem like this, we need to use symmetry. And we can see that if we draw a line right through the middle here, okay, right through 90 degrees, they're symmetrical from 90 degrees to the left and right. Now you can use that, but I'm going to recommend something different, because remember that the 0.9 represents a position measured from 0. So if I use that position measured from 0, 0.9, I'm just going to zoom in a little bit here. Okay, my position measured from 0.9 is being measured in this direction. And I know that the symmetry from pi is going to be the same amount. And I can get to theta 2 by going the exact same amount but backwards. So that little red arrow and the green arrow are actually the same length. I just need to make sure that to get the position, I just need to know where I start and how far I went and in what direction. So this position here is going to work out to be, well, I started pi and I'm going backwards the same distance as I went forward here. So pi minus 0.9. So that then represents one of the positions. So I'm going to call that one theta 2, pi minus 0.9. And I got there using the length here from 0, the length here from pi, and I went backwards the same amount. Now if you take a look at the picture here, well, the other red angles here are just repetitions of each other. They are just jumps of 2 pi. So then to get the other two angles I need, I'm going to do pi minus 0.9, and I'm going to do plus 2 pi, which I'll simplify to 3 pi minus 0.9. And the other one is if I go backwards, so I'm going to start at pi minus 0.9 again, and I'm going to go backwards one full period, so I get negative pi minus 0.9. So those are all 5 positions there. I have 1, 2, 3, 4, 5, and plus the original 0.9 position will give me 6 positions that I'm looking at here. So there they are. There are my 3 positions, or sorry, my 4 positions that I'm looking for. Those 4 right there.